Day, doctor. We are from Group 1. Today we are going to present our assignment 2. The title is Lab View Based Temperature Sensing and Measurement of Oil in Pipeline.
Okay, hi. Now I will explain about the introduction for this project that we are use the temperature measurement and control using the sensor modulus. So for the first point, we explain about the lab view, how the, how the powerful for this lab view is because this lab view is a graphical programming environment for the measurement and control application. So it was the one of the popular application for the temperature measurement using a sensor modulus and implementing a control system using other sensors. For this project, we using a temperature as the temperature sensor. So the requirement that we use, we set up the involvers connecting the analog input on the temperature controller to the output on the panel meter. For the panel meter, it will read the temperature that's sent through the analog input. So for the lab view, will be used to read the analog input and process the temperature data. Next, we use the LED display function that the type that we use for this project. We use three types that the first type is for the minimum temperature display. For this temperature, why we use this minimum temperature is to indicate the lowest desired that temperature setting. For this is typically that used to monitor and maintain a lower temperature limit. So for the next is about the optimum temperature display. For this LED display, we show the recommended temperature value for efficiency. Next, LED display, we name the LED is as maximum temperature. That the function LED that LED will indicate the highest allowable temperature limit. It serves as a visual indication of the upper temperature threshold that should not be the exit to prevent any damage or safety risk. So for each LED display will show the corresponding temperature value. We also use the buzzer that we provide a signal when temperature reach the maximum level. So it will give the alert for user about the higher temperature. Okay, next we talking about the objective of this project. Okay, I will pass for the next presenter. Thank you.
Assalamualaikum. My name is Muhammad Alif Aiman. Today I would like to present about problem statement. So for the first of all, let view graphical programming paradigm and unique terminology can present a steep learning curve for users who are not familiar with that software. Second, let view application can sometimes suffer from performance limitations, especially when dealing with large amount of data or complex algorithm. So it can make problem. For the lastly, while LabVIEW provide a comprehensive set of built-in function and libraries, the availability of third-party libraries and extension may be limited compared to other programming language. This can be a drawback when specific functionality or integration with certain hardware device or software system is required.
Good day, doctor. I am Sasmita Davanathan, Matric CE 2053. Here is the objective for the assignment 2. The first objective is investigate the suitability of LabVIEW as a platform for temperature sensing and measurement in oil pipeline application. The second objective is design and develop a robust and efficient temperature sensing system using LabVIEW specifically tailored for oil pipeline environments. The third objective is implement effective temperature control. Strategize using LabVIEW to regulate all temperature parameters within desired range in the pipeline. Next is scope. The the first scope is design a LabVIEW based temperature monitoring system for oil pipeline. This involves selected appropriate temperature sensors suitable for measuring oil temperature to develop the necessary hardware interface to connect the sensor to the lab view and designing a graphical user interface within lab view for displaying and analyzing the real-time oil temperature data. The second scope is to develop a user-friendly interface using LabVIEW to effectively monitor and visualize all temperature data. So the interface may incorporate buzzer notification or alarm to indicate that the temperature is in lower condition. And the third scope is optimize the LabVIEW based temperature monitoring system for improved performance and efficiency in oil pipeline application. So this is for ensure that implementing efficient data acquisition techniques, optimizing signal processing algorithm to accurate the temperature measurement and fine-tuning the system for improve its reliability. That's all from me. Thank you.
Hello, my name is Roshni Melisha. My matrix number is EE190096. So I'm going to explain on the assignment 2, which is based on LabVIEW. So we have developed temperature sensing and monitoring. So here's the thermometer and then the temperature meter, maximum temperature, optimal temperature and minimum temperature, and then here's the waveform. So here is the block diagram for it. So first now we have to run the system. So here is where we will control the system. So here we can see it is at 42. So when we decrease the temperature, we can see the waveform decreases, changes. So now it is at 18.3 something, nearly to 18. So we can see the minimum temperature is low. It indicates a yellow LED is turned on, which indicates the temperature is low. So action must be taken to bring the temperature to the optimal level. So here we can see the temperature increases as 45, it shows optimal. Because for the oil temperature in the pipeline, the optimal temperature should be within 30 to 50. So it is the optimal temperature. So when the thermometer goes high, when the temperature is really, increases to 87, the temperature meter increases, and then the maximum temperature is high. So we can see the maximum temperature is high, which shows the temperature is not in optimum level and it is high. So we can see the temperature, it shows the buzzer starts to sound. So we can see the buzzer starts to sound, so which indicates the temperature is high. So it indicates the temperature high, so we have to take the action to bring the temperature to the optimum level. So once it is optimum level, then the temperature is in optimal level and the buzzer starts to stop. So this is the stop operation, which shows which stops the operation. So that's all from me. Thank you.
A very good day, doctor. My name is Tanu Silasan of Tamil Selvan. My matric number is CE190175. Today, I would like to explain about the result and analysis for the project 2. So these are the block diagrams. So first of all, this is the thermometer. This is the temperature meter. This one is temperature, and this one is it's to determine whether it's greater or lower. So in this case, if the temperature is more than 60 Celsius, the red light will on. And for this part, we set a range between 30 to 50, whether it shows the optimum temperature, and it will show the green light. While this one is if the temperature is lower than 20 Celsius, the yellow light will pop up. And this one is to run and stop the simulation. And this is the waveform block. So this is the GUI. So this one is thermometer, and this one is a temperature meter, and this one is for temperature reading. And as I said, these are the LEDs for the maximum, optimum, and minimum temperature. And this one is for the waveform of the temperature. So this is the temperature when it's lower than 20. So if the temperature is lower than 20, the yellow light will pop up, which is indicates as a minimum temperature. While if the temperature is in range of 30 to 50, the green light will pop up, which it indicates as an optimum temperature. So these are the waveform. While if the temperature exceed more than 60 Celsius, uh, the red light will on, which is indicate as the maximum temperature, and the buzzer sound will arise. So that's all for me. Thank you.
For the conclusion, to efficiently regulate the temperature process is the biggest problem. Since the temperature process is so highly nonlinear, it is quite challenging to keep the system set point constant. However, SCADA, NeLabVIEW, and MATLAB can all readily emulate it. We utilize LabVIEW in this situation because of its extensive variety of control capabilities. Relay is Relay is utilized as an actuator, hence the simulation result may not match the actual response. In order to achieve the controller output rise along with the process variable, different proportional integral derivative controller values from various tuning methods, however, produce superior and anticipated response. So this is our group reference that our was refer. Uh, we have three reference as you can see. So that's all from my part. Thank you.